Okay, let's talk about a silent killer in your code. Seriously, it's this little performance trap that is so common, I bet you've written it a dozen times without even realizing it. It all comes down to the hidden battle between a list and a set, and today we're going to drag it out into the light. So, I have to ask you straight up, could your go-to, your default, the humble list, actually be the bottleneck you've been hunting for? Stick with me, because by the end of this, you're going to have a super simple, powerful rule to make your code way, way faster. All right, so in this corner, we've got the list. It's familiar, it's orderly, it's reliable. And in the other corner, we have this set. It's a specialist, it's all about being unique, and it's incredibly fast for one specific job. Let's break down what really makes them different. You know, on the surface, the difference seems pretty simple. A list is all about order, and it's totally cool with duplicate items, kind of like a to-do list. A set, on the other hand, only cares about unique things. And order doesn't matter. Think of it like a guest list for a party. You don't list someone twice. But that's not the real story. The performance story is hidden in how they find things. So to really see this thing in action, let's walk through a super common coding scenario. I mean, it's the kind of task we all write, but it's the perfect place to watch this performance trap get sprung. It always starts here, right? You run a query, and you get about this huge flood of data. We're talking thousands, maybe tens of thousands of contact records. So far, so good. And you probably store them in a list, because hey, that's what we do. It's our default. And this is where the trap snaps shut. You're looping through something else. And for every single item in that loop, you have to ask one simple question. Hey, is this particular contact inside that massive collection I just queried? This is the moment of truth for your code. This is exactly where our trusty list, our old friend, completely fails us. That simple question, is this item in here? It becomes a colossal performance bottleneck when you ask it over and over and over again. Here's why. When you use the .contains method on a list, it has no choice but to do what's called a linear search. It starts at the very first item and asks, is this a match? No? Okay, move to the second. How about this one? No? And it goes on, potentially through thousands of records, just to give you a single yes or no. Now, imagine doing that inside a loop that runs 1,000 times. Yeah, your code just grinds to a halt. In the fancy computer science world, this is called O of n complexity. But forget the jargon, okay? Think of it like this. You're looking for one specific business card in a giant disorganized shoebox. You literally have to pick up every single card one by one until you find it. That is exactly what your code is doing with that list. But what if you didn't have that messy shoebox? What if you had a much, much smarter system? Well, this is where the separate comes in to save the day. And the solution is, well, it's almost ridiculously simple. Instead of putting your data into a list, you put it into a set. It's often just a one-line change, but the impact on performance is just massive. So why is it so much faster? Because a set uses this really clever internal trick called hashing. Basically, it takes each item and figures out a unique address for it. So when you ask, hey, is this item in there? It doesn't search at all. It goes directly to that address to see if something's there. It's like magic. This is what's called O of 1 complexity, or constant time. And the analogy is perfect. Forget the shoebox. Now you have a perfectly organized Rolodex. You need to find John Smith's card, you just flip straight to the S tab and boom, it's right there. The time it takes doesn't grow if you have more cards. It's always lightning fast. That is the incredible power of a set. And wow, just look at this. This chart says it all, doesn't it? The lookup time for a list just keeps growing and growing. The more items you have, the longer it takes. That's that huge bar on the left. But for a set, look at that tiny little bar. It's nearly flat. It's almost instant whether you have 100 items or 100,000. The difference isn't just big, it's absolutely dramatic. So the point of all this isn't to say that lists are bad and sets are good. Not at all. It's all about using the right tool for the right job. So let's boil this all down into one simple rule you can take with you. Okay, here's the deal. You're gonna want to stick with a list whenever the order of your items is important, or if you absolutely need to store duplicate values. But, and this is the big one, if your main goal is to do lots and lots of fast existence checks, especially inside a loop, and you couldn't care less about the order, you should absolutely 100% reach for a set. It is a simple switch that can make your code orders of magnitude faster. So I'm going to leave you with a challenge. Go back to your own code right now. Think about it. What is the number one place where swapping a list for a set will give you the biggest possible performance boost? Find that loop, find that .contains call, and just see the difference for yourself. You'll be glad you did.